I'm going to show you a bit more about the I/O function in the J8CM. We'll start by looking at the assembly code over here in the lower right. First, I have an origin statement that's going to um, designate location 10, that we're going to reserve memory location 10 and use that as an I/O buffer for this program. I labeled it with the A, so we'll be able to reference it using that label. The next location, then 11, has a value of 25 in that. I've labeled that as counter 1. We're going to do a loop and we're going to count down from 25 to -1. The program then starts at memory location 20. Here's our start label. And our first instruction is LOD. We're going to load the accumulator with that value of 25. Then we're going to start in our loop. I've got the label for the loop right here, and then that DEC is to decrement the accumulator. So we're going to start counting down that 25 value. Next instruction then is input A, and that is going to take the first byte of data from the input stream, and it's going to store it into memory location 10. After that, then we're going to do an output. So we're going to take what we just put into 10 and we're going to output that to the output stream in the I/O panel. Our next instruction, this JNG, that is jump on negative, and what that's doing is it's looking at the processor status word and the negative bit, and when that gets set, it will jump out of this loop to XYZ. I've cleverly labeled this XYZ down here at location 40. So you've got the org statement saying that this is 40, label XYZ, and that's where we have a halt command followed by the start label so that we load the program counter with the starting location of the program in case we want to run it again. End tells the compiler that it's done compiling. So that's the program that will run, and this next file then I've labeled io_indat.loader, and this file will have the bit patterns that I'll load this into the input stream, and this will be the data that will get read by the program. Now it's all decimal here. In the real world, it would be ones and zeros, but under the covers, really, the J8CM still uses a lot of decimal. I'm going to go ahead and go to the compiler in the upper right here and select 1 to compile the program. Enter io_test1. I don't put the extender on. That's appended automatically. You might recall that from, you know what, I got to back that up. Look at that, I did a capital I. It's case sensitive. I'll test 1. So I go ahead and run that again without the extender, and we can see that it ran and everything. Those messages tell us that it ran fine. We're not going to look at any of the post-compile reports, but I did want to show you one thing. On the main menu now, it has added the option so that after we've compiled a program, if we wanted to go back and look at those post-compile reports, we can go ahead and do that. We won't have any need though. Now in the terminal window down here in the lower left, if I hit, you can see I've got the source code for that assembly language program, and I also have, that's where I have that io_indat_loader file. Now since we've compiled, if I do an ls, you can see that the 4 additional files from doing the compile process have been created. We are going to use the .obj file to load the program directly into memory. The other ones we won't be using in this presentation. So up in the J's 8-bit computer model main menu, I'm going to go to the loader, and I'm going to load the object file, and that is io_test1. Again, I don't put the .obj extender on there. That's done automatically. And now for the loader, I'm going to load that input data file. So that one I created, io_indat.loader. I'm going to go ahead and that will load that into our IO input stream. IO_indat. Okay. Now I return to the main menu and we'll just take a quick look at the IO panel. And you can see on the left here, we have our input data. The output is still empty. And after I run this program, then the output stream will mirror the input stream. It'll also move those IO markers to the end. How far have I gone? There's 20 blocks, so it'll move those IO markers to the end as it reads and writes data. Take a quick look at the memory just to see that we loaded it as stated. Location 11 has our counter in it, 25. We reserved 10 for our IO buffer. The program starts then here at 20, and the halt routine is at 40. So when we jump out of the loop, we'll jump to the halt command and complete the program or finish running it. Okay, now I'm going to go to the front panel and set the program counter to the starting location of the program. So that's 20. Go ahead and exit. In the other presentations, I went and I stepped through the program as to execute it. This time I'm just going to run the whole thing and we'll just look at the output at the end. So it's going to go by pretty quickly here. And you saw it went by pretty quick. So I'll exit out of here and now we'll look at the IO panel. And you can see now that the output stream mirrors the input stream. And if I page forward, you can see that the IO markers have advanced, waiting for the next data to come in or go out, which isn't there. That is it for this presentation. I thank you for watching.